Okay, so we're supposed to sketch the graphs of polynomials. I've included a copy of the notes that I handed out in class, and our first example is given to us. In order to do the x-intercepts, it says we have to set our factors equal to 0, and then we solve for x. So I need to get my standard form into factored form. I don't see a GCF. I do see 4 terms, so I'm going to go ahead and factor this by grouping. And then once I've done that, I need to see if my factors can be factored any further. So I want you to, as soon as I'm done talking, I'm going to want you to pause the video and factor this, and then come back and check your answer. So go ahead and pause right now. Okay, so if you factored everything correctly, you've got x plus 3, x plus 1, and x minus 1. So again, the x-intercepts tell us that we are supposed to set our factors equal to 0 and then solve for x. So if I put x plus 3 is equal to 0, then I can see that x will equal negative 3. If x plus 1 is equal to 0, then x will equal negative 1. If x minus 1 is equal to 0, x is equal to positive 1. So these are my x-intercepts right here. They're all real, so they're all going to be graphed. Now I'm going to look at my y-intercept. That says I just set my y equal to 0, and then, set x equal to 0, then solve for y. In standard form, really all we have to do is look for that constant, because if this is equal to 0, if I put 0 in for each of those x's, all of this part just goes to 0. So I'm left with negative 3. So my y-intercept is simply 0, negative 3. And then my end behavior, I'm going to look at my left and right end by figuring out what's going on with the that leading term. So my leading term in this whole thing was x to the 3rd power. So that means my leading coefficient is 1. It is positive. That means the right is rising. The degree is a 3. That is odd. That means the left is falling. And now I'm ready for my sketch. So in my sketch, it does not have to be drawn to scale. I've got x-intercepts at negative 3, negative 1, positive 1. I have a y-intercept at negative 3. I've got end behaviors where the right end is rising and the left end is falling. Now I'm going to take a look at this turning point. That's something that's kind of new. The turning point says that it has to be 1 less than my degree. No more than 1 less than the degree. If the degree is 3, I can have a maximum number of 2 turning points. My turning points will happen between the x-intercepts, and I don't have any repeated roots or repeated x-intercepts, so I won't have anything that bounces. So I'm going to have a turning point happens between negative 3 and negative 1. I can't put that below the graph, or else that would cause a turning point at negative 3. So I have to have a turning point between those two. And I'm allowed 1 more turning point, and I think that means it will go this way. So that's what my graph looks like. Let's take a look at another example. In example 2, we're supposed to sketch the graph of f of x is equal to 16, x to the 4th minus 25. So again, I'm going to go ahead and factor this, and then we're going to set each of our factors equal to 0 and solve for x, and that's going to give us the x-intercepts. So go ahead and pause now and come back and check your x-intercepts. Now, I haven't completed this entire problem. You can see that I factored this as the difference of squares, 4x squared plus 5 and 4x squared minus 5. Those can't be factored anymore because 5 is not a square term. I then went through the process of getting x by itself, and I'm down to the point where I've got a positive and negative square root of both a positive and a negative 5/4. The square root of a negative is imaginary, so that means this one is just simply going to be imaginary. And then the square root of 5/4 is right about 1.1, so that's what we get here on both of those. I'm just going to go ahead and rewrite this. If it's imaginary, it cannot be graphed, so this is not an x-intercept. So these are real, so these are x-intercepts. Now let's go ahead and find our y-intercept. That's going to be the constant. Looks like negative 25. So that was easy. And my end behaviors, those are going to come from my leading term of 16x to the 4th. So leading coefficient is positive 16. That means the right is rising. The degree is even, which means that the left side is going to be doing the same thing as the right. So the right is rising, the left is rising. Let's go ahead and graph this. X-intercepts are at positive and negative 1.1. I've got a y-intercept of negative 25. I have end behaviors where both ends are rising. And as far as turning points go, I can only have a maximum of 3, which means I can have exactly 3 or less. And turning points happen between x-intercepts, so something like that. You know, it's possible that it does this kind of thing, except without as many turning points. I just don't know that. I'm really just getting the overall idea of what's going on. If you were to actually graph this on your graphing calculator, you would see that the graph kind of flattens out right here before it comes back up. But again, this is my general graph. So this is what example 2 looks like. We're going to try one more example.